Parabolas. Here's just a quick video of what you absolutely must know. And all of this information is on the Google site on the Parabolas algebra page. You should definitely have this in your notes. These are the two standard equations. This is when you have a horizontal axis of symmetry. Notice that the y is squared. And when you have a vertical axis of symmetry, you have the x squared. This, of course, is the one that you guys are most familiar with. Now, one thing to consider that is different from what you learned in the Springboard book last year, the Springboard book tried to always leave everything in the form of a function where it could be written as f of x or so forth. So you saw it last year as 1 over 4p. This is the way that you see parabolas in more advanced college textbooks. So y minus k squared equals 4p times x minus h. Of course, hk is the vertex. The axis of symmetry here is y equals k. And the focus, there's only one in the parabola, it will be at h plus p k. And you're just going to be able to solve for p after you factor out the constant term away from the x value in that case, or away from the y value in this case. So this is our vertical axis of symmetry, x minus h squared equals 4p times y minus k, vertex still at hk. This time the vertical axis of symmetry is at x equals h, obviously because it will be passing through the vertex. The focus will be at h and then k plus p. And then this is the directrix, y equals k minus p. If you want to know more about the directrix, look on the algebra page. I have a whole diagram there going over how the directrix plays a part in graphing the parabola. The hyperbola also has a directrix. We just don't talk about it that much because it's easiest to just deal with a hyperbola in terms of its asymptotes. Okay, a few little notice things at the bottom. Notice what is being squared. That tips you off to how it's opening. So if the y is going to be squared, it's going to have a sideways or horizontal opening. If the x is squared, it's going to have a vertical opening. And your axis of symmetry will be perpendicular to the directrix. Think about that. Your axis of symmetry, which will cut the parabola in half, is going to be perpendicular to the directrix. You can see that right there. So when you have a vertical opening, your axis of symmetry is x equals h, and your directrix is y equals k minus p. So that's just something to think about. And then everybody's favorite, the latus rectum. The latus rectum is a line segment that passes through the focus of the parabola and has endpoints on the parabola. Once again, since it's going to be passing through the focus and having endpoints on the parabola, it will be perpendicular to the axis of symmetry. So if it's perpendicular to the axis of symmetry, it's going to be parallel to the directrix. And this is where the 4p really comes in handy. Its length is equal to the absolute value of 4p. So, of course, you all know about p. You know how the p value, it's related to the a value, and you know that that relates, gives you information about how the parabola is going to open. If the p value is positive, the parabola will open up or to the right. If the p value is negative, the parabola will open down or to the left. Okay, let's do a few problems together. Once again, if you would like some graph paper, you can go to the downloads on our Classes My CCA page, and you can find the link to find this graph paper to help yourself out if you would like some. So, given y minus 3 quantity squared equals 8 times x minus 5, we want to find the vertex, the focus, the directrix, and then we want to graph it. So first thing, what is squared? Well, the y is squared. And if the y is squared, this is going to have a horizontal axis of symmetry and a horizontal opening. So keep that in mind. The vertex is going to be at 5, 3, because there's H and there's K. So 5, 3, that's the vertex. Just listing everything out, and I'll graph it in just a moment. Where's the focus going to be? Well, go back to that 4p value. So 4p is equal to 8. So if 4p equals 8, then obviously p is 2. So let's go ahead and plot the vertex. 1, 2, 3, 4, 5, 1, 2, 3. There's our vertex. We know that this is going to have a horizontal axis of symmetry. So we've got a horizontal axis of symmetry here. I'll do that in yellow. Remember, the axis of symmetry is an auxiliary line, therefore it's going to be broken or dashed. So will the directrix. We'll get to that in just a moment. If p is positive 2, that means that it's going to open to the right. P also tells us how far away the focus and the directrix are from the vertex. So if we go 2 units to the right, that's going to take us to our focus. So our focus is at 7, 3. Remember, only one focus in a parabola. And our directrix will be 2 units back. I'll do that in orange. Remember, it's broken. So there's our directrix. Our directrix is a vertical line. So please, when you give the location of a vertical line, remember it is an equation. This is x equals 3 is the directrix. So we found the vertex, we found the focus, we found the directrix. Let's finish graphing it. Now let's think about this. If 4p, back to 4p, equals 8, the absolute value of 4p is still equal to 8. That is the length of our lattice rectum, which I'll just call LR. So that means that that establishes the width of the parabola. So we can go, if the lattice rectum is 8, we can go up 4, 1, 2, 3, 4 from the focus, and down 4, 1, 2, 3, 4. And of course, I'll show you in pink, this is our LR right here. This is our LR right there. So now we know how wide the opening of the parabola is going to be based on 4p being equal to 8, the LR being equal to 8. Remember, it's a line segment that goes through the focus. It's perpendicular to the axis of symmetry, and it is parallel to the directrix. Now, let's go one step further and let's find one other critical point, because really we've only got one more. Because we do not have a y-intercept, we do have one x-intercept. So let's let y equal 0, and let's find that one x-intercept. And I'm just plugging it into the original given equation. So 0 minus 3 squared equals 8 times x minus 5. So negative 3 squared is 9. And keep solving. Use good algebra. 9/8 equals x minus 5. So plus 5 plus 5. So let's see. 5 over 1 equals 40 over 8. I'll move to the left here. So 5 over 1 times 8 times 8, that's 40 over 8. So our x-intercept is at 49/8. So 49/8. And 8 goes into 49 6 times and some change. That is why we are just on the other side of 6 right there. So we can label that. I'll label it right up here. 49/8. 0. That is our x-intercept. That is everything you ever wanted to know about that parabola. Let's do another one. Given y squared plus 6y plus 12x minus 15 equals 0. Put in standard form, graph, and identify the critical points. Critical points are the focus, the intercepts, if any, and I'll also put on there, find the directrix. Give the directrix. Okay, so here goes. Let's take what's given, and first of all, what is squared? We've got y squared again, so if y is squared, this is going to be a horizontal opening. So remember our horizontal opening. I'll show you again on the notes here. Here's a horizontal opening. Here's the standard form. This is what we're trying to get to, given this expanded form. We're trying to get back to that standard form. So it's going to take some completing this square. So y squared plus 6y, we'll group that together, put everything on the other side, negative 12x minus 15. So complete the square here. So half of 6 is 3, 3 squared is 9. And if we add 9 on the left, we add 9 on the right. So we, not 19, Henry, just 12. Handy dandy emergency correction tape. There we go. So, y squared plus 6y plus 9, that's a perfect square trinomial. It is y plus 3 squared. That's going to allow us to see our k value right there. On the other side, we've got negative 12x minus 6. So we've got y plus 3 squared. I'm going the last step because, once again, I need to know what 4p is equal to. So I've got to factor out that negative 12. So when negative 12 comes out, we're going to be left with x, and then negative 6 divided by negative 12 is going to be plus 1/2. So this is our standard form, which means that we have a vertex of our parabola at negative 1/2, negative 3. Now we can handle negative 1/2. That's not terrible to graph, so we're going to do that. So back a half, down 3, right there. That's our vertex. Now let's look at what else we know. 4p is equal to negative 12. If 4p is equal to negative 12, then p is negative 3. If p is negative 3, and this is a horizontal opening, this parabola is going to open to the left. It's going to be opening to the left. So let's keep that in mind. Next thing to keep in mind is that if p is 3, that tells us where we can find our focus. So let's go ahead and put in that horizontal axis of symmetry as a dashed auxiliary line. And then let's plot our focus. So we're going 3 to the left to find our focus. So 1, 2, 3 to the left. So if our vertex is at negative 1/2, negative 3, then our focus is going to be negative 1/2 minus 3. So that will be right what we can see right there, negative 3.5. Negative 3.5 is the same thing as negative 7/2. So we've got a focus at negative 7/2, negative 3. And our directrix is going to be to the right 3. So 1, 2, 3. There's our directrix. I'll put our directrix in orange. It's at x equals 2.5, x equals 5/2. There we go, that's our directrix. So x equals positive 5/2, that's our directrix. So we're ready to graph here. We're ready to graph. Last thing, if the absolute value of 4p is equal to our LR is 12, which means half of that is 6. The LR is a line segment that passes through the focus. So we're going to go down 6, 1, 2, 3, 4, 5, 6, and up 6, 1, 2, 3, 4, 5, 6, to establish our parabola. And this is what our parabola looks like. So because we're awesome, let's go one step further and notice that we've only got one x-intercept, only one. So let y equals 0. We'll plug it in, we can plug it in the original or we can plug it in our standard form right here, either one. I'm going to go back to the original because it's super simple because we're letting y be 0. It basically knocks out both of those terms. So 0 squared plus 6 times 0 plus 12x minus 15 equals 0. So we end up with 12x equals 15, dividing both sides by 12. 15 over 12, reduce that by 3, so that is 5/4. 5/4. So maybe mine's a little far to the left, but it's looking pretty good. So I've got an x-intercept at 5/4, 0. So there we go. Critical points, directrix, graphed, standard form. We've answered all the questions because we're awesome. One last question. Find the standard form of the parabola if the center is at -1, -3, and the LR is equal to 12, and it opens up. So first of all, if it opens up, and I need to give a correct word. I think I'm still stuck in hyperbola and ellipse land. It's not a center if the vertex. There we go. If the vertex is at -1, -3, and the LR is 12, opens up. Okay, if it opens up, then we know we're going to be going for this as the standard form. If it opens up, then that means x is going to be squared. So if we've got our HK as -1, -3, and if the LR is 12, so that means 4P equals 12, which means P equals 3, and P equals +3 if it's opening up. Let's graph it and see what's happening here. So, first of all, back 1, down 3. So there's our vertex, which means our axis of symmetry is a vertical line passing through that vertex. Okay, and P is equal to 3, so 1, 2, 3. So there's my focus. My focus is at -1, 0. 1, 2, 3. My directrix in this time is a horizontal line at y equals -6. Okay, and because we know that the LR is 12 and that represents 4P, and we know the vertex, we can go ahead and write the equation. So it's going to be x minus -1, so x plus 1 squared equals +12. We know it's positive because it opens up, and then y minus -3, so y plus 3. So this is our standard form. Let's be thorough. Let's go all the way here because this particular parabola, it's going to have a y-intercept and it's going to have two x-intercepts. So let's don't miss out on that amazing opportunity. Let's use the LR. The LR is 12. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here's our parabola. Let me turn it a little so I can draw that nice curve. It's not jagged, it's not pointy, it's a nice smooth curve going through the vertex, and hooray! Because our focus is on the x-axis, then both of our x-intercepts, which are the endpoints of the LR, they're on the x-axis, so we know our x-intercepts. Our x-intercepts are at 5, 0, and at -7, 0. And our y-intercept is super simple. All we got to do is let x equal 0 to find that y-intercept. we can plug it in right here. So that's going to be 0 plus 1 is 1. 1 squared is 1 equals 12 times y plus 3. So I will go ahead and divide both sides by 12. So we end up with 1/12 equals y plus 3. So 1/12 minus 3 is what we need to do here, and that is going to be y equals negative 2 and 11/12. So that would be the same as using my good fraction skill. So that's going to be 24 plus 11. So that is negative 35 over 12 is the y-intercept there. 0, negative 35 over 12. Y-intercept right there. So there's everything we ever wanted to know about that particular parabola. So that wraps it up. Conic sections, awesome.